Hello and welcome to Django and Celery tutorial. You will learn what is Celery, why and when to use it, and how to set up a Django project with Celery and see a few examples of different Celery tasks. What is Celery? Celery is a distributed task queue system for Python. A task queue is like a to-do list for your app. It stores tasks that need to be executed, along with their associated function calls and arguments. Tasks are processed in a specific order, first in, first out. What distributed means? Multiple workers. Celery can distribute tasks across multiple worker processes. These workers can run on different servers, allowing for parallel processing of tasks. Scalability. You can scale task processing horizontally by adding more workers on more servers to handle increased workload without modifying your application. Fault tolerance. If one worker fails or goes offline, tasks can be redistributed to other available workers. Load balancing. Celery can distribute tasks evenly across available workers, preventing any single worker from becoming overloaded. Geographical distribution. Workers can be located in different physical locations or data centers, which can be helpful if workload needs to be performed in different physical locations. Why and when to use Celery? While working with Django, most of our code focuses on responding to HTTP requests from browsers and other HTTP clients. It is important to respond to requests quickly. If a website takes longer than 500 milliseconds to respond, it can start to annoy users. A few seconds to generate a response is only acceptable in rare situations, such as submitting an e-commerce order. By default, Unicorn HTTP server drops the connection if a response takes more than 30 seconds. While your app might not be complex, there are types of tasks that take long time to complete. Applications may need to perform complex and time-consuming operations and interact with other services. For example, sending an email can take anywhere from 50 milliseconds to several seconds. The good news is that some operations can be performed outside the request-response cycle. Back to the sending an email example, if a user signs up, we can schedule sending an email and proceed with generating and sending the response to the client without the delays for actually sending that email. One way to achieve this is by using asynchronous features, but that alone doesn't guarantee successful completion of the operation, nor does it provide a robust control over retries in case of a failure. Additionally, it would be tied to a specific worker process. If it is terminated, then all async tasks are lost with it. This is where task queues and specifically Celery come into play. When you need to perform a potentially time-consuming operation, you send a message to a task queue and move on. The message will be later picked up and executed by a Celery worker process. Common choices for the task queue database are Redis or RabbitMQ. To perform an operation via a task queue, you need to define a task, which is essentially a function wrapped into a task Python decorator. You will then call it in a special way, which will be explained in this tutorial. Another use case for Celery is scheduled jobs. If you want your app to perform a certain operations at specific intervals, such as every 10 minutes, every hour, midnight, or Saturday mornings, you will need a scheduler. Scheduler is a process that waits for the right moment to send the Celery task to the queue. That's its sole job. A scheduler doesn't guarantee the precise timing of execution. It only sends messages at the queue at the correct time. When the execution actually happens depends on the queue worker's setup and the number of tasks in the queue. In some cases, it may not happen at all if no worker is available to process the messages. You can have multiple queues to separate tasks and prevent clogging. For instance, you might have a separate queue for short-lived but important and time-sensitive tasks like sending emails and notifications. This leaves other potentially long-running tasks in a queue where you are less concerned about their timely completion. An advanced use of Celery involves having multiple projects communicate asynchronously via different Celery queues. One application can send tasks that only another application reads from, and vice versa. Unless you need an immediate response from the other application, in which case HTTP calls would be necessary. This method of communication is convenient. The other application, often called a service or a microservice, doesn't need to be running all the time or scaled to handle the workload immediately. It will process tasks from the queue as quickly as it can. A word of warning. While Celery specifically and task queues in general are great for offloading work from request-response cycle. They are not a silver bullet for poorly performing code. You cannot merely offload tasks to the queue and expect performance problems to disappear. You send enough jobs to the task queue, it will eventually take a while for workers to process them. You can scale up the number of workers, but then the database might become a bottleneck, slowing down web requests because background tasks overloaded the database. I hope this introduction has been useful and provides enough context about what Celery is good for, when to use it, and what it actually does. The text version of the tutorial is available at applico.com/celery. Open Bash terminal. Create a directory for your project, switch to it, and initialize a Git repository. We will be using Docker for development of our project. We will not be needing a Python installation outside of Docker. Open your favorite code editor and create these files. Docker file, the essential part of building a Docker image. Requirements.txt, needed to specify and manage Python packages for our project. Docker compose YML, needed to define and manage all the services for our project. Create.env and .start.env files with identical content. .start.env will be added to version control, but not .env. The start file serves as a template for developers to copy and modify locally, ensuring necessary variables are documented without exposing sensitive data. Create.gitignore file in the root of the project. This file lists all files and paths within a project that should not be included into version control. Here is the content of the file you should include for a start, but feel free to add paths that you see fit. For example, temporary files created by your code editor or any other tool. In the root of the project, create a file .dockerignore. Similar to .gitignore, .dockerignore is a list of files that shouldn't be included into Docker builds. It's not super important here, but it can help reduce the size of the build image. In this tutorial, we are not using Python virtual environments on the host, but let's include it here anyway. Including .git folder here also helps reduce the size of the image. Go to the terminal and run docker compose pull to pull all images for our databases. Running this command will make Docker download images for services with defined image attribute and not require the build. This step is optional because they will be pulled anyway on the start of containers. The output of the successful execution of this command should look like this. Now we build Docker image for our Django project. This is an optional step on the first go because the image will be built on container start. But if you change requirements later on, you will need to run this command again. Run command docker compose build. This step might take a while. The output of successful execution of this command should look similar to this. Now it's time to start the Django project. Start a shell within our web container using command docker compose run web bash. Now you will see a bash prompt from within a container. To leave the shell, type exit or press Ctrl D. To start our Django project, type django-admin start project project. Let's get to initial Django configuration. Open your code editor and let's edit some files. First, edit project/settings.py file. Now create a file project/celerapp.py with the following content. This file configures Celery for our Django project, imports necessary modules, loads environment variables, initializes Celery app, configures Celery settings. Now edit the file project init.py. Don't forget to save all files. Now let's apply Django migrations and make sure our project and database connection works correctly. In the Docker bash shell, run this python manage.py migrate. By the way, if you close the shell or you want to run one-off command in Docker without launching the shell, you can do it in another way. Docker compose run web python manage.py migrate. Now we will start containers. This command will start all services defined in Docker compose YML. Run this command outside Docker compose shell. Docker compose up-d. The output of successful execution of this command should look like this. Check logs of your Django project with docker compose logs command to make sure our services are actually working fine. With added -f argument, logs will keep streaming into the terminal. To stop following logs, press Ctrl+C. To show logs for a specific service or services, you can specify their names at the end of the command. Now let's see our app in browser. Please note that if the link with zeros doesn't work for you, you should use localhost. Let's start the Django application. In order to showcase Celery tasks, we need an app where they will live, a model and some views. In Docker shell, run python manage.py start app main app. Create a report model in main app/models.py. Let's create a page which we will use to trigger our tasks. Create a view main app/views.py. Create a template in main app/templates/main app/index.html and add this view into URL-conf in project/urls.py. Add our application in installed apps in project/settings.py. Let's create and apply migrations in Docker. And open our app in browser. Go to github.com/new and create a new repository. When you create a repo, you will be offered with a list of commands. Copy the one that starts with git remote add origin. Now add all files to git and make the initial commit. And paste it in your terminal outside of Docker container shell and run it. Run git push-u origin master. Refresh the GitHub repository page to see that your code is there. You can also check that none of the unwanted files got added to version control. Let's deploy our Django app. Now, this step you might consider optional, but I insist it is very important. You should deploy your app sooner rather than later. By deploying your app as early as possible, you will avoid the situation when you finish the whole project, it works on your machine, but doesn't work when deployed. Deploying your app after you have finished the whole project means the task of debugging would be more time-consuming, and you might end up having to rewrite larger chunks of code. By deploying the project early and often, you make it easier to find the cause of the problem in most recent code changes. Go to Applico dashboard. Add an Ubuntu or a Debian server from a cloud provider of your choice if you haven't already. My personal favorite is Hetzner Cloud, especially their IRM64 VPS servers. Their performance is great and pricing is unbeatable. Create an application from your GitHub repository. From your application dashboard page, go to Databases and add Postgres and Redis databases. Next step, add processes to run your app. From Application Overview page, click Add Processes button or go to Settings Processes. Click Add Processes and add 4 processes: Web, Release, Worker, and Bit. Keep in mind that Web and Release process names are special. The process called Web will receive HTTP traffic from the Nginx, and the Release one is a command that is executed after each successful deployment. The rest of the processes can have any names as long as they consist of letters and numbers, no special characters. Click Save and Deploy, and the first deployment will start. After deployment has finished, click on Open App and then click on the domain name. Our app has been successfully deployed. Applico gives the app a subdomain with your app's name and SSL certificate via Let's Encrypt. You can also add your custom domains in application settings. That was easy, right? Now let's get back to the code. Let's add the first simple Celery task. Go to main app/tasks.py and make the first task. This task doesn't do anything useful, it just waits for 2 seconds, which will be enough to illustrate the potential problem of a long-running code. Let's call it as a regular function from a view. Go to main app/views.py and add another view, dummy and slow view. Create a template, template/main app/generic.html. And add the view to project/urls.py. And update the template main app/templates/main app/index.html to include a link to our view. Now go to our app in the browser. Click on the new link and let's see the result. It took more than 2 seconds for the page to render. This is a very representative example of how long it might take to send a single email. Imagine a person clicked on a sign up button and waiting, watching the browser loading indicator to spin. That's suboptimal experience. Let's make it better. Let's dispatch a Celery task. The simplest way to do that is to go to our view and replace the direct function called dummy and slow with calling dummy and slow.delay method. Now our view should look like this in main app/views.py. Don't forget to stop Docker Compose. To do that, run Docker Compose down and then Docker Compose up-d. Now when you open the URL, you will see this. You see that the execution time of the view itself improved when the Celery task was sent, but the long-running operation is not blocking the request response cycle. We can see that logs don't show any Celery worker activity, although we have sent the task successfully. The reason for that is misconfiguration between the default queue specified in Celery configuration and what queue worker is set to listen to in Docker Compose YML. Let's fix that by going to project/celeriapp.py and changing the default queue from main to default. Restart Docker Compose and try again. Now you can see that task is being picked up and successfully processed by the Celery worker. Let's look into Celery API in more details. Celery task definitions. There are two ways to define a task. One way is to import the Celery app instance and use app.taskDecorator. Another way is using the shared task decorator, which is not tied to a particular Celery instance. The key difference lies in how these tasks are registered and how they behave when multiple Celery app instances are involved. App.taskDecorator. It requires importing a Celery app instance, ties task to a specific app instance. Shared Task Decorator is not tied to a specific Celery instance and is automatically discovered by any Celery app. The not tied to a particular Celery instance aspect of shared task means that it's more flexible and can be easily shared across different parts of a large project without needing to pass around Celery app instances. For many simple Celery setups, this distinction may not be noticeable or important. If you are an author of a library, you have to use the shared task decorator because you can't have your code tied to a particular Celery instance. So, since at the end of the day, shared task doesn't have any downsides and usually there is only one Celery instance in a project, I suggest to stick with the shared task decorator. Like any Python function, your task can be with or without arguments. There are three ways to call a Celery task: using .delay method, using .applyAsync method, and using currentApp.sendTask function. Sending a Celery task via .delay method is the most simple way of sending a Celery task. Instead of calling the function itself directly, you call its method .delay. Sending a Celery task via applyAsync method allows you to pass additional parameters to the task itself as well as arguments to the task function. Here are probably the most important and typical parameters you might want to use while sending tasks. Please do read the official documentation, Celery calling tasks, as there are a lot of caveats and detailed explanations for each of those arguments listed here and some more. Sending tasks via currentApp.sendTask is similar to the applyAsync method, but instead of importing a function, you use the name of the task as a string. The rest is similar to the applyAsync method. Since you are not importing the function but calling the task by name as a string, you have to make sure you know the task name and it won't change when you arrange the code later. For this reason, I recommend specifying the task name in the shared task decorator instead of relying on automatic task naming. This way of calling Celery tasks is also my favorite because it allows to solve the circular import problem when you call a task from a Django model method and the task also imports this model. The current app send task approach also allows to call tasks that are not defined in the code of the current project. That's what I mentioned in the intro about having multiple projects interact with each other via the same Celery instance. You can't import the function, so you have to use sendTask method and pass the name of the function as a string. That means that you have to come up with some sort of a naming convention for tasks, have some prefixes for task names so they don't overlap between projects. For example, give them prefixes with the name of the service, main underscore for the main part of the app, and the service that does video compression, video underscore. This will also help with automatic routing of tasks based on their names. I recommend having some prefix for the project from day one, because if you need to introduce another prefix later, you won't need to fix all the existing task names. Even if you won't need that in the future, it's a good habit to have. One important thing about current app.sendTask. There is a Celery setting called Task Always Eager. If this is set to true, all tasks will be executed locally by blocking until the task returns. This setting will not affect tasks sent with current app send task. They will not be executed without a worker processing it. Let's talk about how to correctly send a Celery task from a view. Usually, when your view is running, all interactions with the database are happening in a transaction. This means that until the view finishes executing, the transaction is not committed, and as such, changes to the database won't be visible from the outside, including to your Celery task. When you create or change a database object and immediately send a task ID with its ID, the task might start before the database update is complete. This can cause errors because the task won't see the recent changes. You might get an object doesn't exist error if the task tries to access an object that hasn't been fully saved yet. Let's see some examples. This code looks fine at first, but the line user objects.get will cause an object doesn't exist exception. It happens because the transaction will be committed after the view finishes, but our Celery task has already been sent. To fix that, we will use transaction.onCommit to run a function that sends our task after a transaction is committed. Let's talk about worker setup. To run a worker, the bare minimum is this command. And here are important arguments you might want to use. Capital Q to specify queues to consume tasks from. Concurrency determines how many tasks a worker can process simultaneously. The log level argument determines the verbosity of the logging output. Hostname or N used to set a custom hostname for the worker. Max memory per child and max tasks per child. Very helpful if you experience memory leaks. When a worker reaches this memory threshold, it will be replaced with a new process after completing its current task. Same happens with the limit on the number of tasks processed. Let's explore a common challenge in web applications: generating reports efficiently as your data grows. Imagine you've built a feature to generate reports in your Django application. Initially, it worked well, especially in development with minimal data. However, as you deploy the application and accumulate more data over time, you start to notice some issues. Report generation time increases significantly. The process blocks the web server, leading to slow response times. Complex reports with multiple database queries and data manipulations became problematic. What was once a simple view function now struggles to handle the increased load. This is where Celery can help. By moving the report generation process to a Celery task, we can offload the heavy processing from the web server, allow the report to generate asynchronously in the background, improve the overall responsiveness of our application. In this example, we'll simulate a time-consuming report generation process using time.sleep function. This simplification allows us to focus on the implementation of Celery tasks without getting bogged down in complex report logic. Let's dive in and see how we can use Celery to handle our report generation more efficiently. Go to main app/views.py and create 3 views: report create view, report detail view, and report list view. And our project/urls.py now looks like this when we import our views and add report-related URLs. Make 5 new templates: main app/report-base.html, main app report form HTML, report list.html, report detail.html. Now, while the rest of the templates are really simple, the last one needs some explaining. The report is available in the report variable. Statuses are defined in the name tuple, report statuses. They have indexes. Pending is 0, running is 1, finished is 2, error is 3. Maybe not the most convenient thing to work with in templates, but I wanted to show you how to use name tuple. If the report is ready, the result and finish time will be shown. If the report has failed for whatever reason, it will state the error. If the report is not yet ready, it will be stated, but also a page will refresh for statuses 0 and 1, which is pending and running. Pending status will be the one when the report is just created. Running, when a worker picked up the task and started working on it. Error is when the task has gracefully failed, meaning reported the failure and saved that to database. Finished, after the task has finished and written the report into the database. Lastly, the template for report contents, which we will use to generate a string and store in the report model field result. The file is main app/report content.html. Modify our model. We need to add a save method, a generate method, and a generate data method. The whole file main app/models.py will look this way. Add a Celery task to main app/tasks.py. Let's break down what's happening. Save method. This is an overridden method for a Django model. When a report is saved with a pending status, it resets the start and finish times. After saving, if the status is still pending, it schedules a Celery task. Transaction on commit. This ensures the task is only sent after the database transaction is committed. It prevents potential issues where the task tries to access a record that hasn't been committed yet. Current app send task. This is a Celery method to send a task to the queue. The task name is main app generate report. It passes the report ID as an argument. Generate data method simulates the actual report generation. It uses time.sleep to mimic a time-consuming process. Report content is generated using a template. Generate method. This is the main method of the report model called by a Celery task. It updates the report status to running and sets the start time, calls generate data to create the report content, updates the status to finished, and sets the finish time. Celery task has a name defined in the decorator shared task main app generate report. It retrieves the report object and calls its generate method. When a report is saved with a pending status, it triggers an asynchronous Celery task. This task runs the report generation process in the background, updating the report status and timestamps along the way. Let's update our main template to include the link to reports and then see how it works. Edit the main app/index.html to include the link. Restart your Docker Compose if it is running. Open our app in the browser. Click on the reports link. Click on the Create Report link. The complexity is just a number of seconds the report will take to generate. Leave it like that, it should be enough for the demonstration. Click on the Submit button. The page will say that the report is in the queue because our Celery task hasn't yet started. After 5 seconds, page refreshes and the report is being generated. 5 seconds later, another refresh, the report is ready. The content of the report is in the orange box. That's it. Well done. You've made it to the end of our Django and Celery tutorial. Let's recap what we've learned. We explored what Celery is and why it's such a powerful tool for handling background tasks. You've discovered how to create tasks that can run independently of your main application. We've delved into various ways to call these tasks, giving you flexibility in your implementations. Together, we've built an example project that generates time-consuming reports with auto-refreshing page that shows awaiting and in-progress screens and displays the final report when it's ready. This tutorial has equipped you with a solid foundation, but there is so much more to discover. Celery is an incredibly versatile tool and allows you a lot of ways to use it. Good luck, happy coding, and happy deploying. Applico can easily deploy multiple apps per server, supports a variety of popular databases, handles backups, and simplifies scaling if your app needs to grow beyond a single server.